Hello everyone. In this lesson, we will learn about what indexes are. As the number of records in a database table increases, the efficiency of executing queries in MySQL can decrease. To address this issue, indexes can be created for tables. A basic table can have multiple indexes created as needed, providing multiple access paths to accelerate data queries. An index is a separate database structure stored on disk, which contains reference pointers to all records in the database table. The functions of indexes can be observed in the following three aspects. 1. Indexes significantly improve data query speed. When using indexes, the index file is first loaded into memory, and the index entries are used to locate the addresses of tuples. Then, the tuple data is directly read into the computer based on these addresses. By reducing the number of disk I or O operations, indexes greatly enhance query speed. This effect is particularly pronounced for large basic tables with a high volume of data. 2. Indexes ensure data uniqueness. The definition of an index includes specifications for ensuring data uniqueness. When data input or modifications are made to the corresponding indexed items, the system performs checks to ensure the data's uniqueness. 3. Indexes accelerate join operations. When performing join operations between two relations, the system needs to perform query operations on the join fields for each connection. This can result in a significant workload for the queries. Obviously, if there is an index on the join field of the connection file, the join operation can be greatly improved. Therefore, many systems require the connection file to have a corresponding index in order to execute join operations. For example, to perform a join operation between the student and selection tables, it is required to have an index on the student ID foreign key in the SC table. Otherwise, the speed of data connection operations would be significantly slower. Creating an index is an effective way to speed up data queries. When creating an index, users should follow the following principles. 1. Index creation and maintenance are the responsibilities of the DBA and DBMS. The creation and deletion of indexes are performed by the DBA database administrator or the DBO table owner. That is, the creator of the table. Other users cannot create or delete indexes arbitrarily. The system automatically selects and maintains indexes. This means that users do not need to specify the use of indexes, open indexes, or perform reindexing operations on indexes. These tasks are automatically handled by the DBMS. 2. Indexes should be created for large tables. While small tables may not require indexes, the more records and the longer the records in a table, the more necessary it is to create indexes. The effectiveness of speeding up query speed becomes more apparent with the use of indexes. On the other hand, for small basic tables with relatively few records, the significance of creating indexes is minimal. 3. Avoid creating excessive indexes for a basic table. Index files occupy file directories and storage space, and having too many indexes can burden the system. Indexes require maintenance, and when data in the basic table is added, deleted, or modified, the index files must be updated to remain consistent with the basic table. Obviously, having too many indexes can slow down data insertion, deletion, and modification operations. 4. Create indexes based on query requirements. Indexes should be created based on the demands of data querying or processing. Indexes are particularly beneficial for data with high query frequency and real-time requirements. However, for other types of data, the need for indexes may not be a consideration. Based on the syntax of index implementation, there are generally 5 types of indexes, including ordinary indexes, unique indexes, primary key indexes, full text indexes, and spatial indexes. Ordinary index. It is the basic index type in MySQL, defined using key or index without any additional constraints, and its purpose is to speed up data access. Unique index. Defined using unique index. A unique index requires adding a uniqueness constraint on the indexed field, and it is used to prevent users from adding duplicate values. Primary key index. A special type of unique index defined using primary key. It uniquely identifies each record based on the uniqueness of the primary key itself, and prevents the duplication or inclusion of null values in the field specified as the primary key. Full text index. Defined using full text index. It is used to improve the query speed of fields with a large amount of data based on the search characters. This index requires the field type to be one of char, varchar, or text. Spatial index. A spatial index is defined using spatial index and is created on spatial data type fields. To improve the efficiency of retrieving spatial data in a system, spatial indexes are supported only in the MyISAM and InnoDB storage engines, and it is also necessary to ensure that the indexed field is not null. Based on the number of fields used for creating an index, they can be further classified into single-column indexes and composite indexes. Single-column index. It refers to an index created on a single field in a table. It can be an ordinary index, unique index, primary key index, or full text index, as long as it corresponds to a single field in the table. Composite index. It is created on multiple fields in a table. However, the index will only be used if the query conditions involve the first field in the index. Short answer questions. Multiple choice questions. Select one answer choice. Multiple choice questions. Select more than one answer choices. We have covered the concepts, creation principles, and classifications of indexes. We hope that everyone has understood and mastered them well. Goodbye, class.